Hi everyone, welcome back to Leetcoding. I'm your host Faraz. So in this video we'll be solving the Leetcode contest, and the contest is just about to start. So let us go to the contest. The thing is, I just woke up and I'm feeling very sleepy right now. Let's see how the contest goes. It will start in 18 seconds. Till then I will show you my channel. So this is my channel and this is the free interview preparation series. So if you are preparing for the interviews or if you want a quick revision for the interviews, you can follow along with this series. And yeah, this series is from scratch, starting from the very basics, so you can follow along with me. Now let us start the contest and see how it goes, because I'm very sleepy right now and I just woke up like 5 minutes ago. Maximum ascending Subarray sum. Given an array of positive integer nums, return the maximum possible sum of an ascending subarray in nums. 65. Here it is 65. 5. Okay. Alright, so basically we have to find the summation of the we have to find the summations of all the increasing subarrays, like 10, 20, 30. It will be 10 plus 20 plus 30, that is 60. Then next increasing will be 5, 10, 50. So basically these are like increasing subarrays and we have to find the summations. So let us keep the answer initially as 0. Now going for int I is equal to 0, let us just make the answer as nums of 0 starting from the first number. Okay, then from I is equal to 1, I is smaller than nums dot size I plus plus. Now if nums of I, this current element, if it is greater than the previous element, that is nums of I minus 1, then in this case it is increasing. So answer plus, alright, okay, int, let me just make this as answer. This will be the maximum of all those summations summations that we are going to do for the increasing subarrays. So this is 0 and this is the summation that I'm keeping. Okay, so summation plus equal to nums of I. Alright, otherwise if this is not the case, then this we should go to the else condition, and now answer is equal to maximum of answer comma this summation. Okay, and finally after coming out of this loop, this summation will have something. So again answer is equal to maximum of answer comma summation. Let us see if it is working. Even my typing becomes slow when I'm sleepy. I don't know why. So it is not giving me correct answer. It's not giving me correct answer. Yeah, when this is not the case, then I should also make the sum as 0 here. Otherwise I will end up taking the summation of the entire array as the answer. So it is giving me 65. Wow. I should not make it 0, rather I should make it as nums of I. Okay, now we are getting 65. Let us see by running all the test cases. 65, 150, 33 and 100. I hope it get accepted, because yeah, it got accepted. Next, let us move to this question. So number of orders in the backlog. Backlogs. You are given, okay, yeah, just wait a second. I'm just explaining it because I am here to explain you, not to simply do the contest. In the first question we had the peaks, something like this, increasing, then again increasing, then again increasing. We had to find the summation of these increasing parts. Okay, these increasing parts, we have to find the summations. So basically what I did, I start taking summation starting from here, and then I kept comparing, like if we are on this element is greater than this, okay, If you are on this element is greater than the previous one. If you are on this element is also greater than the previous one. So I picked the summation till this point, and as soon as I compare these two elements, like if this element is actually greater than this, no, it is not the case. In that case, this was the summation, and I compared the summation with the answer, changed the answer accordingly, and then start taking summation of this part. So I made sum is equal to nums of I. Yeah. This was the line number 17. Okay, so that's how we did it. Then again for this part, and when I came to this particular position, again this was the summation, changed the answer, moved the summation to here. That's how we did it. Now, number of orders in the backlogs. You are given a 2D integer array orders. For each order I, there's price I, amount I, and the order type. Denotes that the amount I order have been placed of type order type, and the price this much. The order type pi is 0 if it is a batch of buy orders, or it is 1 if it is a batch of sell orders. Note that order I represents a batch of amounts I. What the hell is this question, man? Note that order I represent a batch of amount I independent orders, the same price and order type. All order represented by order I will be placed before all order represented by order I plus 1. For all the valid I, there is a backlog that consists of orders that have not been executed. The backlog is initially empty. When an order is placed, the following happens. If the order is a buy order, you will look at the sell order with the smallest price. What the hell is this questions getting me mad. I'm moving on to the next one. You are given 3 positive integers, an index and sum. You want to construct an array nums. We are given n, we are given index, we are given a sum. We need to construct nums, 0 index, that satisfies the following conditions. The size of nums should be equal to n. Nums of I is a positive integer between 0 and n. Absolute value between these two is smaller than equal to 1. Where okay, sum of all, okay, is it should not exceed maximum sum, is maximized. Oh, okay. Return nums of index for the constructed array. Alright, I got it. So that value should be maximized. Now if I have that value, it should not exceed, right? Yeah, maximum. Okay, alright. So basically what I'm thinking, the first intuition that that have come to my mind is like, this is the array that we want to construct, and there's a certain index in the array that should be maximum, right? This index, this should be maximized, and total size is n. The difference between consecutive elements should be smaller than equal to this, and everything could be between, so the positive between 0 and n. So the maximum number that we can keep there is n, and maximum sum. Alright, so maximum sum, these are constraints, like the total summation of the entire array should not exceed this. That is what it is given, right? The sum of all the elements of nums does not exceed. Okay, this is one of the constraint. Other constraint is n, like all the elements inside this should be smaller than n, should be starting from n minus 1. All the elements that I place should be smaller than n minus 1. So basically, if I try keeping here n minus 1, okay, if I try keeping here n minus 1, then I know that how many elements are there at this side, how many elements are there at this side. All right, so yeah, so what we can do is, like, if we place a certain element here, let's say if we place x here, okay, then here we will place x minus 1, x minus 2. Why x minus 1? Because the difference between these two elements, okay, the difference between these two elements could not exceed 1. Okay, so we can either place x minus 1 here, or we can place x plus 1 here. But if we place x plus 1, it will be a disadvantage, because x plus 1 will add, like, it will make the total summation of the entire array much larger. Okay, but we want to minimize the total summation of the entire array so that we remain within the given constraints, that is maximum sum. That is why we want to minimize the total summation. That is why we want to use small elements, okay, instead of big ones. So I will not use x plus 1 here, I will only use x minus 1, and at this position x minus 2, at this position x minus 3. Okay, similarly here also, at this position also I had two options. Like, if I use x minus 1, I will have two options. One option will be used will be to use x, other option will be to use x minus 2, but I will be going with x minus 2. Why? Because I don't want to exceed the total summation of the array more than maximum sum, which is the constraint. So that is why this is what I'm thinking on the first hand. So starting from x minus 1, I will go till something like x minus y, depending on the number of elements which are on this side. And I know that how to take the total summation of these, like how to take the total summation of the series, from series like 5 plus 6 plus 7 plus 8. Okay, I know how to take the summation of this series in a constant time. There is a formula. I can simply take the total summation. Similarly, I can take the summation for this side. Here also the same story, starting from x minus 1, x minus 2, x minus 3. Okay, I know how to take the total summation in constant time. So this is what I was thinking. But yeah, yes, yeah. Basically, if I increase x, okay, if somehow I increase x, this will also increase, this will also increase total summations. Okay, now let me jump to the mathematical formula. Okay, how many elements are there? Like, if this is the index, this is the index, I am denoting it by I. How many elements are there on the right hand side? So 0, 1, 2, 3, 4, 5, 6. Size of this array is 7. Okay, the index is 3. So 7 minus 3, that is 4, minus 1. These many elements are there. This is actually 7 is n minus I minus 1 elements are there on the right hand side. How many elements are there on the left hand side? N minus I, that is 7 minus 3 minus, I think these many elements are there on the left hand side as well, according to the mathematical formula. Not actually. Like, if it would have been, if I was 4, then 7 minus 4 is 3, minus 1 is 2. This is correct. This is for the right hand side. This is correct. For the left hand side, 7 yeah, actually the elements on the left hand side, it is simply equal to the index I. Okay, yeah, these are the number of elements on the left hand side, these are the number of elements on the right hand side. Okay, yeah, now you know these elements, and I can simply apply the formula. What will be the formula? So basically, for the left hand side, the formula will be x minus 1, x minus 2, and so on till x minus I. Okay, so this is the we have to find the summation of this. So this plus this plus this. Okay, this will be actually equal to, how many terms are there in total? In total there are I terms. In total these are I terms. So x into I minus 1 plus 2 plus so on till I. Okay, so that will be, this will be equal to x into I minus n into n plus 1 divided by 2, that is I into I plus 1 divided by 2. So this is for the left hand side. Similarly we can calculate for the right hand side as well. So in the right hand side there are these many terms. So instead of I should plug n minus I minus 1. So that is how we will get the summation for the right hand side as well. Alright. Okay, let me just write it at the same time so that it is not complicated at the end. So I'm creating this function. This function will give me the summation of the entire array, or rather the summation of the left hand side and the right hand side. So it is going to give me the summation. So for that I will pass the number of elements. So int elements. Okay, and I should use this formula here. So this formula is x into I, and I should also pass x here. So return x into I. What is I? I is the number of elements, right? So x into the number of elements minus x into number of elements minus number of elements in, okay, elements into elements plus 1 this thing divided by 2. So this is going to return me the total summation, and I will calculate the summation for the left hand side and for the right hand side. Yeah, I can simply do a linear search here, like but the number of elements could be this much. Yeah, so instead of doing a linear search I will do a binary search. I cannot do a linear search because it is 10 raised to the power 9, and 10 raised to the power 9 it will not work in big O of n. It will work in log n. So I will do a binary search instead of a linear search. How a binary search? Basically, how could I have done a linear search? So in the linear search I could have placed here n minus 1, then I would have checked the total summation of the right hand side and the left hand side plus n minus 1. If it is greater than this maximum limits, I will reduce it from n minus 1 to n minus 2. Okay, again I will check this summation plus n minus 2. If it is also greater than the total summation, then I would have taken n minus 3 and then try it. So then again n minus 4, and as soon as I get something like if at n minus 3 if at n minus 5 I got the total summation smaller than maximum sum, then I would return that the maximum element is n minus 5 here. Okay, but this is a linear search. Okay, we are searching the solution linearly. We are going step by step, reducing one at a time. But instead of doing this I can use a binary search also. Okay, again, if you haven't watched enough videos of binary search, you can go to my playlist, the free interview preparation series, and you can find a lot of lectures on binary search if you want to learn it from there. So I will do a binary search. So for that I will keep 2 pointers, start and end. End will be equal to n minus 1 because this is the maximum that I can have, and start will be equal to 0. This is the minimum that I can have. But wait a second, like all the numbers should be there's another condition as well. The condition is all the numbers should be positive. So I don't want that these numbers x minus 1, x minus 2, x minus 3 they become negative. I don't want that. So whichever is larger, like if there are more numbers on the left hand side, then the chances are that the negative element will become on the left hand side. If there are more number of elements on the right hand side, the chances are this element x minus something will become negative on this side. So I want to avoid both of these. So for that, let us say if I have more number elements on the more number of elements on the right hand side, then in that case, let's say if I have 5 elements on the right hand side, okay, so in this case what I will do is I will not keep any number here which is lower than this number 5. If I keep 5 here, then also I think if I keep 5 here, then 4, 3, 2, 1 and 0, yeah, I can go till 0. So I can keep element 5 here because there are 5 number of elements on the right hand side. I can keep an element 5 here, then I will go from 4 till 0. I cannot keep anything that is smaller than 5. So that should be my start. So my start should be such that these elements doesn't become negative in future, these elements, okay. So for that I will have to compare how many elements are there on the left hand side and how many elements are there on the right hand side. On whichever side there are more elements, I will have to handle the situation for that one. So start should be equal to maximum of the number of elements on the right hand side, that is, let me just denote it index by I comma n minus I minus 1, the maximum of these two, okay. Now again starting a binary search, so for that, while start is smaller than equal to end, and int mid will be equal to start plus end minus start divided by 2, this is mid. Now we have the middle position, and I will be checking the conditions. So int, this is for the left hand side, L is equal to summation of number of elements in the left hand side is I, and the element that I am using here is mid, okay. Mid is the element that mid is the X that I am using here. This is what I want to keep at the position I, okay. Finding the summation for the right hand side, number of elements on the right hand side is equal to how much? n minus I minus 1. These many elements I have on the right hand side, and again this is the element that I'm choosing to put at the position I. Now finally, if L summation on the left hand side plus summation on the right hand side plus whatever we are keeping at the index I, if this thing is actually smaller than or equal to, can we take equal to? The total summation element does not exceed, so if it should not exceed, that is why we can take equal to as well, equal to maximum summation. If this is the case, then answer is equal to maximum of answer comma mid, okay, because this is what we are trying to keep at this position and we are trying to maximize the answer. Let me just create the answer as well. Answer is equal to 0, and this is the answer. And if we are able to find the answer, then we will try to see if we can find the answer with even a greater value. So the greater value, for the greater value, start should be equal to mid plus 1. That's how we do binary search, right? Otherwise, and again I'm saying for those who don't know binary search, please go to the free interview preparation series. The link is in the description. You will find a lot of lectures on binary search and a detailed explanation as well, so just go and watch that. Return answer. Let us see if it is working for the test cases. 2 and 0. 2 and 0. Why? In this case the index is given as 1, maximum summation is 10, okay. Start is n, that is 6 minus 1 minus 1, that is 6 minus 2, 4. Start is 4. Start is 4, but all right. So I could have, I can reuse the numbers as well. Yeah, I can reuse the numbers as well. Okay. um the difference between, okay, yeah, I got it. So basically, I yeah, the thing is, like, as I told you that these numbers can go negative, but we can avoid them going to negative, because as soon as I reach 1, so basically I will be going like this, right? X minus 1, x minus 2, x minus 3, so this will be something like 5, 4, 3, 2, 1, then 0, then minus 1. So let us just ignore it. Okay, let us just ignore this minus 1, and instead of minus 1 I can simply keep 0 here as well. Okay, I can just keep putting zeros in those places. Simple. I can keep putting zeros. So so yes, yeah. I should handle this total summations. Okay, this function sum. So basically, if the number of elements here, let us talk about this side, because it is much simple to talk about the left hand side. The number of elements on the left hand side are actually equal to I. So we talk about the left hand side. So in this case, let us say I'm going like this: x minus 1, x minus 2 till x minus I. And if this x minus I is negative, I should only go to the till the point we have 1. Alright, this should not become negative. hmm. Awesome, yeah. So this would actually handle that case. Let me just try to run this first with taking s as 0. Awesome. Let me just submit this. Hopefully, no, it doesn't get accepted. Why? The output is 2. It should be 7. Total number of elements are 3. Total number of elements are 3. And the size is, the n is given as 2, where I is between this. Oh, okay. Actually, there are no limits for I thought the maximum number that I can keep is n, but it is not the case. It is not the case. I can keep something greater than n as well. So why don't we just keep it as int max? If I do that, I will be able to get correct answer for this test case as well. But there's something that we need to handle when we use int max. That is integer limits. Okay, integer limits should be handled. So for that, I'm using long. Let us do hash define ll as long. Now I will be using ll at all these places. Here also ll. Let us see if it is working now. Correct answer. Submit. Wrong answer. Output is 5. It should be 4. Nice. Damn. Oof. This is the condition, man. Like this, summation I minus I plus 1. Absolute difference, right? So this is correct only. The absolute difference. This is not an issue. Why is this test case? If okay, here n is given as 7. Let me just copy this test case and So this is the test case. The total summation should not exceed 14. Total number of elements are 8, and we are talking about the 7th index. Okay, we are talking about the 7th index. Okay, total here 8, 1, 2, 3, 2, 3, 4, 5, 6, 7. We are talking about this particular index. So for this, I took 5. When I took 5 here, expected is 4. When I took 5 here, this is 4, 3, 2, 1, 0, 0, 0. Okay. Total summation is 9. 9 plus 5 is 14, 115. It is exceeding. Total summation is exceeding. So let me just print out what is my left summation and what is my right summation when mid is equal to 5. So if mid is equal to 5, print out L and R. Give me the for this particular test case. Okay, seven and 0. So it is not giving me correct summation. For the left hand side, it is giving me 7. I don't know why. In the left hand side, I'm sending I. Now this I and mid. I'm basically sending what is I? I is 7. I is 7. Okay. All right. Okay. Now I understand one thing. I need to change this formula somehow so that it gives me correct summation. Now total number of elements on this side, total number of elements on this particular side, and even on the right hand side, this is not equal to I. This is actually equal to minimum of I comma the element that we are using here. And the element that we are using here is something that we are keeping at this position, -1. Okay, mid -1. This, so this I should be sending, so that is minimum of I comma mid -1. Okay. Whichever is smaller. That many elements I should be using. Because all the elements are 0. So, or in other terms, what I can say is I can simply use m-1 as well. Like, these many elements will be there. These many elements are going to be there, and here also I can use m-1. These many elements could be there. What happened now? Mid -1 actually. Like, these many elements could be there. Oof. I am getting 10 for this side. 4 plus 3 plus 2 plus 1, that is correct. But why for the right hand side am I getting 10? Like for the right hand side, yeah, I should be using minimum. Yeah, minimum of this comma mid minus 1 and minimum of this thing comma mid minus 1. And minimum of long, and this is okay. The function minimum, it only takes arguments which are of the same type. So it is giving me correct answer now. Let me just run this again for all the test cases. It is giving me correct answer. Let us now try to submit this and hopefully it will get accepted. I should remove this condition. This was just for testing purposes. Oh my god. Expected one. We are talking about the 0th index. There are 4 number of elements. Total summation cannot exceed 4. Let us just test for this one as well. Let me just get rid, and it is 404. 404. No, 4 number of elements. Talking about the 0th index, 4 number of elements. Total summation cannot exceed 4. Now the answer that I am returning it for here is 2. Now if I keep 2 here, I should keep 1 here, 0 here, 0 here. Total summation will be 3, and that is quite acceptable. But they want me to return 1. Why should I return 1? If I keep 1, this will be 0, 0, 0. Total summation is 4, man. Did I read something wrong in the problem statement? Did anybody actually solve this question? Oh my god, 172 people have already solved this one. So note absolute x should be greater than, note that absolute, okay, return nums of index of the constructed array is maximized, okay, as a positive integer. It could be equal to 0 as well. What should be the value of can't we have zeros as a positive integer? This should be a positive integer, right? This cannot be equal to 0. Okay, this cannot be equal to 0. So basically I cannot go smaller than 1. So if I keep 2 here, if I keep 1 here, then I should like keep pushing ones. Okay, I should keep pushing ones. So for all the places that I am having, I should keep 1 there, not 0. Okay, so let us say if I reduce something like this, 4 3 2 1 1 1 1 1, I should keep pushing ones instead of zeros. So okay, I will handle that. So as I told you, I have this summation. This summation is correct, but I need to add something more into the summation. So the left hand side, what I have to add is the extra elements, like whatever I have passed among these two values, I and mid minus 1. So so let us say if the number of elements, that is I, if this is greater than the number that we are placing there. For example, let me take the new page. This is the position I'm keeping some value mid, and this is mid minus 1, right? This is mid minus 1, and I will start going back from mid minus 1, mid minus 1, mid minus 2, mid minus 3, and so on. And the number of elements here are I. Now if this I is greater than this mid minus 1, then I will be having some number of ones, otherwise I won't have. So how many number of ones do we have, are we going to have? That is I minus this thing. Okay, So this L left plus is equal to maximum of 0 comma I minus mid minus 1. There is I minus mid plus 1. And similarly handling it for the right hand side. So for the right hand side it will be L plus is equal to maximum of 0 comma, now instead of I will be using n minus I minus 1 minus mid plus 1. Okay, should see if it is working. Again the call to maximum. Okay, I should make this 0 as long. The functions minimum and maximum, they keep arguments of the same type. Did I lose that? Okay, I should run it for the case 404. Should give me 1. Yes, it is giving me correct answer. Let us just run this for all the other test cases as well. This question took a lot of time and it got accepted. Finally it got accepted. I hope you understand this one. Okay, now I don't feel like moving on to the next question or to the second question, because second question seems to be very bad to me. I know it is simple, I know many people would have solved this, but this question is quite lengthy. I don't want to solve this. Alright, I'll just stop here, just try to solve rest of the questions, and I'm feeling very sleepy. I will upload the solutions as soon as the contest is over. I will try to solve the second question. I will try to understand the problem statement, but it's going to take a lot of time. Like, I'm feeling so lazy right now. You can try solving it. Also the fourth question, I will look for it. Okay, it is a XOR question, I think. Count pairs with XOR in range. Okay, I will just see the solution. I will just see if I can get the solution in time right of the contest. If I will be able to do these questions second and 4, I will upload the solutions. Otherwise you can obviously find the solutions in the discuss section, okay, after the contest. If I manage to do it, if I don't feel lazy, then I will upload it. Otherwise you can go to the discuss and find it. Again, you can follow my free interview preparation series, which I have been covering here. You can watch the lectures and follow along. Okay, thank you.